Okay, so this is part 2 of 8.4. 8.4 part 2. Here we go. So this next one, crazy, right? The square root of 2/3 plus the square root of 6 plus the square root of 1/6. So there are multiple ways of chasing after this problem to simplify it together. They're wanting us to add that together. And so your choice on how you start off. I thought make all of the terms simplified. So make that term simplified. Then make that term simplified. I can't split my fingers to do it. And make that term simplified. Actually, the one in the middle is simplified. So, but make the two outer ones. And so that we can do that. So that's going to be the square root of 2 over the square root of 3. And why it's not simplified is because you got a square root in the, I had a square root of a fraction. Now I have a square root in the denominator. So I'm going to multiply by the square root of 3 over the square root of 3 so that I have a perfect square here. So that's going to be the square root of 6 over 3. And the 6 and the 3 will not reduce. You know why? Because one's underneath the square root and the other is not. Okay, so now this is simplified. So this fraction is this fraction. They're equivalent to one another. And it is in simplified form for radical. So I'm going to write the next one as plus the square root of 6. And what the heck, I'm going to write it over 1. He's a fraction, so he got jealous and wanted to be a fraction too. And so I'm going to write them both as fractions. And put my plus a little better. And then here, my thought, that's the square root of 1 over the square root of 6. And the square root of 1, friends, is 1. But I'm gonna wait on that because I'm going to multiply to get the square root out of the denominator to simplify it by the square root of 6 over the square root of 6. So this becomes, and it's plus, 1 times 6 is the square root of 6 over 6, right? The square root of 6 times the square root of 6 is the square root of 36, which is 6. And so hot diggity dog. And now I've got fractions with no radicals in the denominator. So that's easier to get a common denominator. So I'm going to have to find the common denominator, which is, I hear people out there in YouTube land, my algebra friends screaming, it's 6. The common denominator is 6, right? So I don't know if this pen will work. Oh, it did. Well, I don't know. It's not looking good. Utensils at my house are not good. The pencils are eraserless, all of that. And so I'm trying to manage because trying not to go out to stores, you know. And so multiplying by 2 over 2, that's the special one there. So the square root of 6 times 2, you cannot multiply them together because one's underneath the square root and the other is not. So this is 2 square roots of 6. You write the number first and the square root second over 6 plus, and then I want a common denominator 6. So maybe you should put it on the other side, silly, I'll say. So put it on the other side, times 6 times 6. And so this is the square root of 6 over 6 plus the square root of 6 over 6. And now they all have the same denominator, and so I can add them together by adding their numerators together. I can physically add their numerators together because they're all square roots of 6. And you just add the coefficients. So 2 plus 6, that's 8, plus 1 is 9. So 9 square roots of 6 over 6. And the 9 and the 6 could reduce with one another, and they do. They both will divide by 3. And so one more step, divide this by 3, I get 3. I didn't do anything with the square root of 6, so this won't reduce at all. It's these two that are reducing. And 6 divided by 3 is 2. So there is our answer. And we did a lovely job on it. Okay, and then 2 more problems that they ask us to do. And here they're asking us to rationalize the denominator and, if possible, simplify And when you have a binomial, you multiply by the conjugate. And I haven't told you what the conjugate is. And I want to show you the conjugate. I'm going to come down here on the bottom of the paper because I didn't give room. Okay, so the square root of 15 minus 3 has a conjugate, and its conjugate is the square root of 15. So squiggly line over here is the conjugate, plus 3. So those things are conjugates of one another. Another thing that 2 square root of 3x minus 5 square root of 2x, the conjugate of it, right, so I'm going to list the conjugate over here. These would be conjugates of one another, is the same thing except for a plus in the center. One more. So if you had the square root of 2 plus the square root of 3, the conjugate would be the square root of 2. You just change that sign, minus the square root of 3. People always ask, well, what if I had negative x plus the square root of 3? What would be the conjugate? Well, it would be negative x minus the square root of 3. So we did some, just find the conjugate, and what you have to do is multiply by the conjugate. And so I don't want any radicals in the denominator. And so, but that radical isn't just the square root of 15, it's the square root of 15 minus 3. And so if I multiplied by the square root of 15, like I was doing up there, it wouldn't get rid of the, it would get rid of it here, but it wouldn't get rid of it there when I had to distribute it. And so that's why you multiply by the conjugate, because remember when we multiply these things together here, so I'm going to multiply here, the square root of 15 plus 3, and you have to do to the top too, the square root of 15 plus 3. And when I multiply this times this, do you remember that you do FOIL, but do you remember what happens to the outer and the inner? They make 0. So it really is just becomes the first and the last. So I'm going to just write the denominator right now. That line wasn't very straight. But the square root of 15 times the square root of 15, if you like, is the square root of 225. Oh, is it 225? Yeah, it is. 15 times 15 is 225. And the square root of 225 is 15. If you're saying, I knew that was going to be 15 without finding it was the square root of 225. Yeah, you're right. And then here, when I do, that was the first, and here is the last. So that's minus, now that's not underneath the square root, so that's minus 9. And see how it got rid of the square root in the denominator because the outer and the inner made 0. And the square root of 15 times the square root of 15 made the perfect square, 225, and got rid of the square root. Pretty tricky, right? And so what that gives me for my denominator, 15 take away 9 is 6. I always like to wait to multiply my numerator together because this often happens in the problems that they give me, not every single freaking time, but quite a bit. And do you notice that that 6 and this 6 will reduce with one another? So if I multiplied this together, then I would have to factor out a 6. So that's the reason I'm not going to multiply this together, because I see that, hey, if I multiplied and then factored, I've chased my tail, and the 6's reduce with one another. 6 divided by 6 is 1. So this answer right here is the square root of 15 plus 3. That's what this is equivalent to. And so we did a lovely job on that. When you look in the back of the book, they might write 3 plus the square root of 15. It's all good. Those are the same. So perfect. Okay. The next one over there, I notice that you got square roots in the denominator, and I say to myself, oh, I have to multiply by the conjugate in order to get rid of when you have a binomial. So if I had a monomial, it's different. But when I have a binomial, you have to multiply by the conjugate. If you're wondering, what do you do if you have a trinomial over there? And good news, you don't have to worry about it. So, so I'm going to multiply here in the bottom by the conjugate. 2 square root of 3x plus 5 square root of 2x. And I'm going to do the same to the numerator, because what you do to the bottom, you got to do to the top. And so you don't do one a plus and the other a minus. They're both plus, plus, plus. They're the same. So this should be the special one. This was the special one. They're equal to one another. Now, when I multiply, and I am going to multiply the denominator together because I'm watching for, will I get a 19 or will I get an x? Or will I get something that what reduces with a 19? So things that reduce with 19 are multiples of 19, like 38 and whatever 19 times 3 is, 57. And so I'm looking for that. Or will it reduce, will I get an x or x squared, because that'll reduce. And so often they have them reduced, and so we'll see if it reduces. So again, the FOIL, right? So I'm just going to worry about the first and the last. So when I multiply the first together, the numbers in the front, the coefficient, 2 times 2 is 4. Then my square roots, that's the square root of 9x squared. And I know that people are yelling at me, but isn't that just 3x? And you're right, it is. So I'm going to write that here. That's 4 times 3x. And so, but I wanted you to see that I just multiplied the parts, right? It's just that because that's a perfect square, it's going to be lovely. So it's 12x. So we just did the first, right? Now we're going to do the last. So that's going to be minus 25 times the square root of 2 times 2 is 4x squared. So this is minus 25 times 2x. I don't have to worry about absolute value. They forgot to tell me here in the directions that it's positive on the variable, but that's what they're assuming. And so this is 50x, so this is minus 50x. And so my denominator is, drum roll please, right? So if you're looking at my numerator and thinking you got nothing in your numerator, you're right, I don't. That's not the same as having nothing in your brains, nothing in your numerator. I'm going to come back and get my numerator. But I wanted to see what my denominator is before I did that. And it's negative 38x. And remember what I was telling you about when we started with the 19x, that often it reduces. So that tells me don't multiply this together. So this is in the numerator, 19x times that, 19x times that, right? 19x times that. Usually I'd be too lazy to write this. So this is here, 19x times, what was it? I'll write it now. And here this reduces. X divided by x is 1. And the 19 and the 38 reduce with one another because 19 or 38 can be written as 2 times 19. And so I'm going to do that, and I'm going to just erase it. So instead of 38, I'm going to write 2 times 19 times x. And I'm going to reduce the 19 divided by 19 is 1. And x divided by x is 1. So that leaves negative 2 down here in the denominator. And that negative can be written out to the side when you have a negative in the denominator. So this is a negative out to the side. And in the numerator here I have 2 square roots of 3x plus 5 square roots of 2x all over 2. And woo, that was a problem, right? I think that's actually a problem in your book, and I had problems with problem number, and I didn't have the book with me, and so I had problems typed out, but not the problem numbers, and it was you might find that problem as an even in the book. You can go and look. Okay, so that's the end of 8.4, right? 8.4. Boy, woohoo! We did a good job.